Today we're going to look at finding equations of a body on a slope. So if there is no movement and we want to find what forces are acting upon this object, we have to keep in mind that there are opposite forces which are preventing it from moving, such as static friction. So static friction will be moving up the slope, and what is making this move down the slope would be gravity, and therefore it's perpendicular and its parallel component. So we need to find those out. Obviously, as well, since we have a perpendicular component, we must have a normal component. Right. Now, in terms of this, our normal component is just equal to the gravity component with perpendicular. And our gravity component is going to be on the same side as our angle. So it is adjacent. So it would be FG, which would be over there, cos of the angle theta. Right, easy enough. Now, what we also need to say is that the force of gravity, which is parallel, is negative to the force of friction, which we are given, or we need to find out. And the force of gravity, which is parallel, is equal to Fg sine of theta. Alright, now once you found out Fg parallel, then we can find out what force of friction is. Then we can use that the force of friction is equal to mu s times Fn to find mu s. Alright, because once we find that, we do that, and we got that, we got this. So all we need for this is that we must make sure that we have mass, and that's about it. Or if it's on Earth, then we have the acceleration due to gravity. Alright, okay. Now, the differences come if we get into the idea of a frictionless slope. If we have a frictionless slope, that means we do not have a force of friction acting up. All we have is the force of gravity acting down, the normal force acting up, and now we have a net force. Now, in some of these equations, you need to find what the acceleration will be. Well, first and foremost, you need to find the net force acting down. And if the net force acting down is going to be the force of gravity, which is parallel. So we know that the force of gravity, which is parallel, is equal to the force of gravity times it by the sine of the angle theta of the slope. Therefore, once we've got all of those, we can find that F net is also equal to the mass times acceleration. In order to find that, we now have F net, which is our force of gravity. And we've been given our mass, which is mass. So therefore, once we rearrange it, acceleration is just the net force divided by the mass, which would equal our answer. Right, don't forget the unit and the direction of motion, which would be parallel down the slope. Okay, that's more or less all we need to know for our object sliding down the slope or being held on a slope.